ThermaSkirt is very much a performance-orientated heating system, and it outshines many alternatives both in terms of overall comfort and energy usage. It's tested by VisRIA to EN 442-1, which is the standard industry test for radiators. ThermaSkirt H2O is available in two main profiles. We make the BM2 profile and the BM3 profile. Now, on a standard boiler, ThermaSkirt BM2 will kick out around 120 watts per linear meter, whilst the BM3 will kick out around 180 watts per linear meter. If you're running it as a low flow temperature heating system, so on a heat pump, it's going to be around 50% of that, so 60 watts and 90 watts respectively. So even at low flow temperatures, ThermaSkirt can kick out a considerable amount of heat, and that's due to the overall surface area of the system and the fact that it's manufactured out of aluminium. For those of you who want a nice quick and easy conversion of ThermaSkirt length to standard radiator size, we have a nice little conversion table which you can find on our website. Unlike radiators which rely on convection, ThermaSkirt is an infrared radiant heater which kicks out heat at a low level around the perimeter of a room. When VisRIA ran their tests, they used a 4 meter by 4 meter room, one with a 800 watt radiator in and the other with 800 watts of equivalent ThermaSkirt. The room that was heated by the radiator had a 4.8 degrees C temperature differential from the hottest to the coldest part of the room, where the ThermaSkirt only had a 1.8 degree differential. So you can see here from the thermal mapping how much more even and consistent the heat is that ThermaSkirt can produce. Now when they're running hot, radiators can create very powerful convection current. So because there's a high temperature differential between the radiator and the room, that promotes strong air movement which helps distribute the heat evenly. However, when you go to low flow temperature systems, the convection currents of those radiators significantly reduces because there's not enough temperature differential between the radiator and the room to promote that air movement. As a result, if a room has, say, a 500 watt heat loss and you install an equivalent 500 watt radiator, on paper it looks like you've got enough heat to comfortably heat that room. However, in reality, what you end up with is a room that is much hotter on one side than the other. And as a result, you get very, very low levels of thermal comfort. ThermaSkirt, however, distributes its heat much more like underfloor heating, at a low level right the way across the room. So let's look at the ThermaSkirt's performance in action. This case study is a case study from the University of Salford. Now, in this climate chamber, it's a one-of-a-kind testing environment. Now, this chamber is pretty incredible. It can heat the environment up to plus 40 degrees, minus 20 degrees. It can make it windy, it can make it rain, it can make it snow. And really what this facility is designed to do is to test heating systems to failure. Now, what we're looking at here on the thermal image is actually footage from inside the chamber. And you can see that the environment is around -6, -6.5. Now from the outside of the building, you can see the air source heat pumps in action here. So on the extract, you've got a very, very cold side, and then on the inverter where the pump and the compressor is, it's quite warm. Now you can see on the external side of the building that you've got around -6.5 on the external walls. And what that indicates is the house is losing hardly any heat. Now, as the footage continues on, we go into the house, so you can see the ThermaSkirt actually in action, and there you have it. So from a marketing perspective, this was great for Barratt because they wanted to show how effective their house could be heated even when it's -6 outside. In this particular instance, there's ThermaSkirt fitted right the way through the Barratt's house, running on a Valent air source heat pump. The house next door is a Bellway house which is installed with radiators on an air source heat pump. So Salford Uni can do a direct comparison between the two properties to see which one performs better overall. One of the things to take away here from this footage is how evenly spread the heat actually is in the room. So the walls, the ceilings, the floors, the kitchen units, they're all around 24, 25 degrees. They're all heated to within 1 degree of each other. And that's with the ThermaSkirt running at 35. The main thing to take away from this video is that the thermal performance of ThermaSkirt speaks for itself. It creates a very evenly heated space, which maximises thermal comfort and minimises overall energy use. So there's a common misconception that your heating system heats you up, and that is not the case. The average comfortable room is around 20 or 21 degrees C, and the average human being is around 34 degrees C, as you can see from the thermal imaging here. You see, human beings operate in this Goldilocks zone where we don't want to be too hot and we don't want to be too cold. If you lose heat too quickly, then you feel cold and you want to wrap up. If you lose heat too slowly, then you feel hot and stuffy and you want to open the windows. So good thermal comfort is not so much about specific room temperature, it's actually about controlling the rate at which we lose heat. Importantly, the function of a heating system is to offset a building's heat losses that the insulation fails to cover. So buildings with a high level of insulation have a very low heat requirement, and buildings with a very low level of insulation have a very high heat requirement. The majority of a room's heat is lost through the external walls and glazing. So by positioning ThermaSkirt in the areas of highest heat loss, we offset that heat loss where it's most present. ThermaSkirt creates what we call a thermal envelope around the room, which offsets the heat losses and boosts the overall thermal comfort. Another misconception is that once you've furnished a room, you impact the performance of the ThermaSkirt. And that's not the case. Your heating system is not heating you up directly, it's mitigating the heat losses. So if you have heat loss, thermal envelope, and then furniture on the inside of that envelope, you're effectively creating a barrier for that heat to get out. That way, if you furnish the room, you really don't impact the overall performance of the system because the furniture is sat within the interior of the thermal envelope. ThermaSkirt provides an efficient and consistent performance by utilising radiant heat at a low level. By offsetting the heat losses where they're most present, you can boost overall thermal comfort even when the heating system is not necessarily switched on all the time. Let's have a quick look at a specific use case.